Hi students, this video is on the chapter The Human Eye and the Colorful World, Part 3. In this video, now let us discuss the refraction of light through a prism and the dispersion of white light by a glass prism with an examples. Now let us see first what is the refraction of light through a glass prism and what is a prism. The prism is a transparent refracting medium. It is a what? Transparent refracting medium. So bounded by at least two lateral surfaces. Bounded by what? At least two lateral surfaces inclined to each other. Inclined to each other with a certain angle. With a certain angle. And the prism has two triangular bases and three rectangular lateral surfaces. The angle between the two lateral surfaces is called as the angle between the two lateral surfaces is called this angle is called as the angle A is called as the angle of the prism, and it is denoted by the symbol A. Now, what happens when a ray of light passes through a glass prism? When a ray of light passes through a glass prism, it gets bent twice at the air glass interface and the glass air interface. First, it bends what at the air glass interface, and second time it bends at the second surface AC. That is, the second time it is what at glass air interface. Now in the figure you can see here this PQ is the incident ray and N dash N dash is what the normal to the refracting surface at the point of incidence. Now a ray PQ after refraction at air glass interface, it bends towards the normal. It bends towards the normal. EF is what? The refracted ray here. It bends towards the normal because area of light entering from what? Air medium to glass medium, that is rarer medium to denser medium. Now what happens at the second surface AC? At the second surface AC, the light ray enters from glass to air so that it bends away from the normal, away from the normal. So here this RS represents what? RS represents what? The emergent ray. This RS represents what? The emergent ray, and A is the angle of the prism. So incident ray, refracted ray, and this is emergent ray. I is the angle of incidence, R is the angle of refraction, and E is the angle of emergence, and D is the angle of deviation. Now how to define the angle of deviation? What happens? So this angle of deviation, it is the angle at which the emergent ray makes an angle with the incident ray. This is incident ray extended forward, and this is emergent ray extended backward. Now the angle between these two, this angle D is called as the angle of deviation, and this angle of deviation is depends upon what? The angle of the prism. Depends upon what? The angle of the deviation. The angle of the deviation is depends upon what? The angle of the prism. So the emergent ray, when passes through a glass prism, it is deviated by an angle to the incident ray. This angle is called as the angle of deviation. So the next point is the dispersion of white light by a glass prism. That means when a white light enters the prism, what happens with the emergent rays? So the phenomenon of splitting of white light, the phenomenon of splitting of white light into its constituent colors when it passes through a prism is called as the dispersion. What is dispersion? The phenomenon of splitting of white light into its constituent colors when it passes through a prism is called as dispersion. And this band of seven colors so obtained, the the jar, that is what, violet, indigo, blue, green, yellow, orange and red. This band is called as the spectrum. This is called as what, the spectrum. And the Isaac Newton was the first one to use a glass prism to obtain the spectrum of light. Now, what is the cause of dispersion? Why the dispersion occurs? The light rays of different colors travels with the same speed in vacuum and also in air. But in any other medium, they travel with different speeds. They travel with what? The different speeds and bend through different angles, which leads to the what? The dispersion of light. What is the cause for dispersion of light? The ray of light travel with the ray of light travel with same speed in air or vacuum, but when it enters the other medium, the ray of light travel with different speeds with and they bend through what, different angles, which leads to the what, the dispersion of light. So red light has the maximum wavelength and the violet light has the minimum wavelength. So in any medium, the red light travels faster and deviates least, while the violet light travels slowest and deviates maximum. That is, the wavelength of the light is inversely proportional to the deviation. So red light has the maximum wavelength, it bends least, and the violet light has what, the minimum wavelength and it bends largest. So this is what the cause of dispersion. So next one is what, the recombination of the spectrum of white light. It produces what, the white light. Now what happens, the Newton showed that the reverse of dispersion of light is also possible. So what he done, the experiment, he kept two prisms close to each other. He kept two prisms close to each other. One is in erect position and another one is what, in inverted position. The light gets dispersed when passes through the first prism. So dispersion occurs in the first prism. Now in the second prism receives all the seven colored rays. It receives all seven colored rays from the first prism and recombines them into original white light. Recombines into original white light. This observation shows that the sunlight is made up of seven colors. The this observation shows that what, the sunlight is made up of seven colors. Any light that gives the spectrum similar to that of the sunlight is called as the white light. So this is about the what, the recombination of the spectrum of white light. So the next example is rainbow formation. Now let us discuss about the rainbow formation. So a rainbow is a natural spectrum. A rainbow is a natural spectrum appearing in the sky after a rain shower. So how it is caused? It is caused by the dispersion of sunlight by water droplets present in the atmosphere. So it is caused by what? The dispersion of sunlight by water droplets present in the atmosphere. That means what? The water droplets acts like a small prisms. So this water droplets, they refract and disperse the sunlight. They refract and disperse the sunlight, then reflect it internally and finally refract it again when it comes out of the raindrops. So due to the dispersion of sunlight and internal reflection by the water droplets, we see what, the rainbow colors. So finally rainbow constitute what, three phenomena: refraction, dispersion as well as what, reflection. So due to these three phenomenon, rainbow formation takes place here.